Alright, let's get our hands dirty and dive into the fascinating world of engineering drawings. Whether you're a seasoned engineer or just starting out, understanding how to communicate complex ideas on paper is a skill that sets you apart. Picture this. You're tasked with building a complicated part. Let's say a custom gearbox for a high-precision robot. Every gear, shaft, and housing needs to fit perfectly, and there's no room for error. You hand over a technical drawing to your machinist, but it's covered in a confusing web of dashed lines. It's hard to tell what's inside and what's outside, and even harder to visualize how everything fits together. Hidden lines are meant to reveal the interior features, but when there are too many, the drawing starts to look like a plate of spaghetti, tangled, messy, and almost impossible to interpret at a glance. When you're forced to guess which dashed line represents which feature, mistakes can happen. And in engineering, mistakes aren't just inconvenient. They can be expensive, time-consuming, and even dangerous. This is exactly where sectional views come to the rescue, transforming confusion into clarity. Instead of leaving things to the imagination, we slice the part open on paper, just like cutting a cake to see all its layers inside. This approach makes the invisible visible. Suddenly, those confusing dashed lines are replaced by bold, solid lines that clearly show the internal features. The drawing becomes much easier to read and understand. Now you can instantly see the profile, wall thickness, and how every component fits together. It's like having X-ray vision for your designs. Think of it like looking at a house. The exterior tells you what it looks like from the outside, but a floor plan reveals the rooms, walls, and hidden spaces inside. Sectional views do the same for mechanical parts. By eliminating ambiguity, sectional views bridge the gap between two-dimensional drawings and the three-dimensional reality of the part. They make sure everyone is on the same page. While a standard orthographic view only shows the outside surfaces, sectional views reveal the hidden details inside, features you'd otherwise miss. That's why sectional views are essential for clear, precise communication between designers and makers. They help prevent misunderstandings and ensure the part is built exactly as intended. In this chapter, we'll explore the different types of sectional views: full, half, offset, and more. You'll learn the rules for creating them and tips for using them effectively in your own projects. By the end, you'll have the confidence to reveal a part's secrets on paper, making your drawings clear, professional, and easy to understand. No more second-guessing or costly errors, just smooth, efficient building. Let's get started and unlock the power of sectional views together. Dive in and see how sectional views can transform the way you design and communicate in engineering. So, what is a sectional view? Let's break it down in simple terms. A sectional view is a special type of drawing that shows what an object would look like if you could slice it open, almost as if you were cutting it in half to see what's inside. Imagine taking an apple and slicing it right down the middle. Suddenly, you can see the seeds, the core, and all the details that were hidden beneath the surface. That's exactly what a sectional view does for mechanical parts and engineering designs. In engineering, we use an imaginary cutting plane. Think of it as an invisible knife to reveal the internal geometry of a part or assembly. This allows us to look inside complex objects without actually destroying them. By exposing these hidden features, sectional views turn invisible details into something you can measure, analyze, and discuss directly. This is crucial for manufacturing, quality control, and troubleshooting. There are a few key terms to know: the cutting plane line, which marks where the slice is made; the direction of sight, which tells you which way you're looking; and section lines, also called hatching, which show the solid material that's been cut through. The cutting plane line is usually bold and dashed, making it easy to spot on a drawing. It guides your eye to the exact location of the slice. Arrows attached to the cutting plane line indicate the direction you're supposed to look after the cut is made, ensuring everyone interprets the view the same way. Section lines, or hatching, fill in the areas where solid material has been cut. These lines make it clear which parts are solid and which are empty spaces or holes. When you put all these elements together, you get a powerful communication tool. Sectional views help teams collaborate, spot potential issues, and make informed decisions quickly. Instead of a confusing web of hidden lines, you get a clean, easy-to-read picture of the part's interior. This clarity is essential for both designers and manufacturers. Sectional views aren't just about making drawings look nice. They're about making information accessible. A well-drawn sectional view removes ambiguity, reduces errors, and ensures that anyone, from engineers to machinists, can understand the design. That's the mark of good engineering and effective communication. Today, let's take a closer look at some of the most important tools in our sectional view toolbox. Tools that help engineers and designers communicate complex internal details with clarity and precision. Sectional views are essential for understanding the hidden features inside mechanical parts, and each type serves a unique purpose. The full section is the workhorse of sectional views. It slices straight through the entire part, revealing everything inside as if the object were cut cleanly in half. This method is perfect for symmetrical parts, as it displays the complete internal profile in a single, easy-to-read view, making it simple to spot any internal features or cavities. The half section is a clever approach, showing both the exterior and interior of a part in one drawing. It's like getting two views in one. This is especially efficient for symmetrical parts, as it saves space and reduces the need for multiple drawings, while still providing all the necessary information. The offset section is designed for parts with staggered or non-linear internal features that a straight cut would miss. Here, the cutting plane bends or jogs to pass through all the important features, allowing you to display multiple details in a single, comprehensive view. The aligned section is used for angled features, such as spokes, bolt patterns, or holes that are not parallel to the main axis. It rotates these features into the plane of the section, making them appear as if they are straight, so you can see their true shape and size. This technique ensures that the feature is shown at its actual size and precise location, which is crucial for accurate manufacturing and inspection. Each type of sectional view, full, half, offset, and aligned, serves a specific purpose, helping you choose the best way to communicate your design intent. Selecting the right sectional view is key to making your drawings clear, concise, and easy to understand for everyone involved in the project. Remember, sectional views are all about making complex parts understandable. Use them wisely to ensure your designs are interpreted correctly and efficiently. Beyond the main types, we have specialized sections. The broken out section shows a small internal feature without a full cut. It's like peeking inside without opening the whole lid. The revolved section is for long parts with consistent cross-sections. It superimposes the cross-section onto the main view. The removed section shows a cross-section elsewhere on the drawing. It's useful for crowded geometries or multiple cross-sections. These sections handle awkward geometries elegantly. They solve specific communication needs. Knowing when to use each is a mark of a skilled drafter. Communicate design effectively. Sectional views have rules for clarity. Hatch lines are thin, black, and uniformly spaced, usually at 45 degrees. Consistency and clarity are key. In assemblies, change hatch angles for adjacent parts. This distinguishes components visually. Don't hatch standard parts like bolts or ribs parallel to the cutting plane. The cutting plane line is a thick phantom line with arrows. Label it clearly, like AA, to link the cut and view. For simple parts, labels might be omitted. Clarity is the goal. Follow these rules for effective communication. Sectional views should be clear and unambiguous. They are a visual code for builders. Let's put this into practice with a flanged bushing. It has a central bore, keyway, and staggered bolt holes. Hidden lines would be a nightmare, so we use an offset section. The cutting plane zigzags to capture all features. Draw the cutting plane line in the top view, labeled AA. Arrows point down, replacing the standard front view. Project features to create Section AA. Hatch lines show solid material. Voids remain empty. Ignore the jogs in the cutting plane for a continuous view. This reveals the bore, keyway, and bolt holes clearly. Sectional views simplify complex parts. Creating a great sectional view is only half the battle. Dimension it properly for clarity. Place dimensions where features are most visible. Avoid dimensioning to hidden lines. Keep drawings uncluttered and strategic. Use center lines for symmetry and dimensioning. Break hatch lines around dimension numbers for readability. Reduce cognitive load for the machinist. Use GD&T callouts for internal features. Connect tolerances directly to features. This ensures the final part functions as planned. Clarity and precision are key. Avoid common mistakes in sectional views. Incorrect hatching is a big blunder. Never hatch standard hardware or ribs parallel to the plane. Label views correctly to maintain connections. Dimension to visible lines, not hidden ones. Choose the right section type for the part. Analyze geometry for the best section choice. The right choice makes the drawing clear. Avoid confusion with thoughtful sectioning. Precision and clarity prevent costly errors. Before sending a drawing out, run a mental checklist. Is the section necessary for clarity? Choose the best section type for the part. Check the cutting plane line and labels. Inspect hatching for consistency and clarity. Review dimensioning for clarity and placement. Use center lines effectively. This isn't just about rules, it's about empathy. A clear sectional view respects the machinist's time. It prevents errors and frustration. Turn ideas into reality efficiently. Stop guessing. Start building with confidence.